Thank you. Today I would like to, it's my honor to give you my recent work. The title is A New Horizon of FinFET with internal gate and negative capacitance. I'm very happy to present our work, and I would like to give you next slide. We are thinking about what is post Apple, because Apple is coming to the saturation and coming down. Yeah, right. So what post Apple, and we are talking about what is the post Google or post Microsoft. So some people talking about that what is more than more. More than more is always discussed in many international conferences, and maybe not rarely, but we would like to provide a solution. What is more and more? We are talking about how is the fundamental device working for the future of post Google era. So we are developing so-called energy efficient device. We are aiming on a very high energy efficient device. Maybe the efficiency can be 10 times better than present one. 10 times or 20 times or even 50 times or even 100 times. So we are addressing this kind of device. And I would like to introduce you how we made it. And also not only high efficiency, but also high performances, including all those things. High speed, high on current, low off current, because high on current, it can perform a very high performances and very low power. And the low voltage, because low voltage, it can give you a very low energy consumption. And even more importantly is that how do you make a low noise device? It's very, very critical, very, very important. So how to make a very low noise device. And all of this, it is concluded with a very small substrate strain. This is a very important factor to address about all kinds of high efficiency, high performances devices. And Taiwan now become a world leader in semiconductor. We are number one in semiconductors. And among those companies, TSMC become the world leader of nowadays they are working on 10 nanometer. And the 10 nanometer will be delivered end of this year. It is leading, and Intel is a little bit behind. We are world leader in this technology, and we are also developing 7 nanometers, 5 nanometers. Even recently, we are developing 3 nanometers. The density is extremely high. Therefore, density high, therefore cost it can be very effective. All my students working on this. And one generation, the chairman of TSMC, Morris Chang, told me that each group, each generation, there are more than 3,000 researchers working on this. 3,000 researchers working on this. Spend a lot of money, so it's not easy. Only a big company can make it. However, we had dinner together, and Morris Chang, we are very confident about his achievement. But he said he just remember 30, 40 years ago, what the foundation ever made in Taiwan. He's thinking about this kind of things. So I think that's very important. How Taiwan established a strong foundation for semiconductors. Nowadays, 100 universities working on semiconductors. Thousands of students working on semiconductor. So therefore, it's a very strong foundation. And the TSMC has grown from 13 billion to 26 billion, double in 3 years. And the world market share is more than 50%. That means really TSMC is a world leader in semiconductors. Yeah. However, nowadays we are not only talking about the present semiconductor, we are talking about what is the future of semiconductors. So there is the article mentioned that it's time to reinvent the transistor. It's a time to reinvent the transistor. And I would like to try to address you how we made it. Okay, thank you. So this was in 1965. In 1965, there's a very famous papers by Gordon Moore. This is a very famous Moore's law, Gordon Moore, in 1965. And he addressed that this is the origin of VLSI. This is the origin of VLSI. At the same time, in 1965, we established all kinds of semiconductor technology in our university with the same thing. This is exactly the same thing. This is the teardrop type. This teardrop type is the same thing and the characteristic. So we established a very strong foundation since then. And then we established the National Nano Device Laboratory in 1990. I think this is earlier than Nano Initiative in USA. It was the year 2000, signed by President Clinton. Okay, so we know that. So nowadays, this has become a very important national laboratory to support the Nano Device Laboratory in Taiwan. Not only in Taiwan, maybe it can be internationally also very, very important. And then we also try to establish another national program because we are very successful in semiconductor manufacturing, but we want to promote our semiconductor design capability. Therefore, we established a national SoC SiP program, silicon on chip program, system on package program. That's also a very critical one. And in order to that, we also established a CPU IP design company, Andis, and nowadays become number 2 in the world, just next to ARMS. So I think it will be a very important action to promote semiconductor in Taiwan. This chart just showing that how Andis perform better than ARMS. In the dynamic power, is 32% better. In power efficiency, is 62% better. And the maximum frequency performance is 43% better. Although NT is still number 2 in the world, not the number 1, but I believe and I think we could be better, much better in the future. We already struggled for 10 years for these companies, but now it's come to a success. I hope we can do something more in the future. Let me see. And because of promote this national program, Taiwan became number 2 in the world in design capability. Number 2 in the world. This chart shows that USA is still number 1 in design silicon in SoC design, but Taiwan become number 2. This is Taiwan. This is Japan. We say we are number 2 together with Japan. Actually, we are better than Japan. Okay, I hope. And then I would like to address you our new concept and how do we realize this kind of concept. The basic concept that is very simple. We use negative capacitance. We put negative capacitance into a gate oxide. Usually, gate oxide form a capacitance that is a positive capacitance. It's a normal capacitance. But we put negative capacitance into the gate oxide. And in order to make a more efficient control of the channel, so how do we work and how do we achieve to do that? But there's a simple equation to describe about because the energy efficiency is very important. Therefore, how power consumption is square of voltage. That's very important. And also important to off current to on current ratio. That's very important. This is a static power consumption. This is the dynamic power consumption. Both. We address both. Should be very important. So I will use this equation to explain our later presentations. Yeah. So I would like to, because this is a very important, simple but a very important equation to describe, to explain how we can make it very efficiently and energy saving and a fast speed, high frequency, and a low noise. It's very important. So we can do all the things. I don't know why we can do all the things. It's also impossible, but we made it. We made it. That's very important. And also, this only one research center can demonstrate this kind of concept. The only one. We demonstrated in last year VSI conference, and we present our new achievement in the coming VSI symposium in Hawaii this in June. Yeah. So this we are really on the top of the world to demonstrate all those kind of concepts come to realize.